So the exam is on only chapter 5. I put an outline up on As You Learn. Yeah, review for the final, and it tells you what problems, and we'll go over them. Let me get the book up. Start. The take home's gonna have, I think, 4 or 5 questions on it. I picked one from each, but then there was this other one that I wanted you to, it's just a definition, but I wanted you to explain it and see what your thoughts were on it. So that's the extra problem. So there's 5, 10 points each, 50 points. And then the in class will be between 8 and 12 of them. This is the review. The in class is 8 to 12 questions. I was going to take 3 from each, but depending on if they're longer, then it's only going to be 1 and it's covering a lot of it. So it's around 8 to 12. Like some of the probabilities, instead of having them all the same thing, I might have different ones, but they're very short. And then the contingency table, I would probably only have 1 or 2. So somewhere between 8 and 12 questions, and I'll know for sure on Monday. Be able to draw graphs and read graphs. Create a contingency table, read a contingency table, similar to attendance problems. And these examples, all the definitions are at the end of each section. They have the definitions, but you also could use the sheets that I put on As You Learn that we do our information from under outlines. And it would be 5.1, 2, 3, 4, and this was some contingency tables that we did. I put the review for the final here also, so that way, depending on where you look, it's in both spots. The in-person portion of the final is Wednesday, May 10th at 8 a.m. It is an hour exam, but you have 2.5 hours to do it. But it's just like a regular exam. It's not longer. But you have as much time as you need. Take-home portion is due May 11th at 11:59 p.m. along with any late material. So if you're turning in projects or attendance problems, they have to be turned in by May 11th at 11:59 p.m. so I can get them graded. If you are missing an in-person exam, there's a couple people, they had an excuse for missing, but then they never set it up. So you could still take that, but it has to be before May 11th or by May 11th. And you could also take it during the final when you finish the final if you want to take it then. Any questions? I have it's a different class, it's business calc, but they're taking their final on Monday If you have another test on Wednesday and you'd like to get it over with sooner, you could take it at Monday at 8. Just let me know. I'll have to send you the link. Any questions? Okay. I think the best thing is to look at the problems. They start on page 337, 5.1. Let me shrink this. Now, some of these are the same thing, but there we go. The first group was 1 through 9. Now these are asking for a mean, median, mode, range, quartiles. If we look at the first one, we could do a lot of the stuff just from one. But this one says calculate the median and the quartiles and determine if there's any outliers and draw a box plot. Now, the first thing you have to do, and if I put this on an in class, it will already be in order. Simply because I know you know how to put something in order. I'm not going to test. Looks like 5 and 12. The 26, 27, 22, 23, 23. No 24. There's a 25 and 3 26s. $27, $29. Am I missing any? $30, $33, and $40. Squeeze them in there. I think I got them all. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. Okay. So the first thing you need to do is make sure they're in order. Now we need to find the median. The median is the middle number. Notice though, there's an even number, and that's why I put that line there. So the median is here. When it's even, then you add the 2 middle ones and divide by 2. Now in this case, it's the same. So our median's 26. This line splits your data. So the bottom one is the lower quartile. The median at the top is the upper quartile. 1, 2, 3, 4, 5, 6, 7. So the middle, 3 on each side, is 23. Then find the median at the top, and that's your upper quartile. What's the median of the upper half? Anyone?
29.
Because if we go from each side and go in, 3 on each side would be 20. Any questions so far? 5-number summary. Since we have to do a box plot, is your smallest value. Your lower quartile, median, upper quartile, and largest number. Our smallest 5, our 2 quartiles 23, 29, and the median's 26, and our largest value is 40. In order to make a box plot, you need those 5 numbers. Starting with your lowest of 5. I'm going to go by 5. 5, 10, 15. And then over each number, you want to draw a vertical line. So over 5, 23, 26, 29, and 40. So you just draw a vertical line for each of these. You box in the middle, and they call them whiskers. Draw lines to the end. This is 25% of your data. This is 25%, and so on. So 25% of the data is below 23. The median was 26, 15% of the data is below it, and 50% is above it. Any questions on the box plot? Now it's asking about outliers. To find the outliers, you first need to find the inner quartile range. The inner quartile range is subtracting the 2 quartiles. So it will be 29 minus 23. Any questions so far? To find outliers, They're below the lower quartile minus 1.5 times the IQR and above the upper plus 1.5 IQR. Lower quartile was 23 minus 1.5 times the IQR. So any values below 14 are outliers. And then to find the upper one, upper quartile was 29 plus 1.5 times 6. And above 38. So if we look at our data, anything below 14, right here, below 14. So there's two of them. Now it said, determine whether there are any outliers. So yes, there are outliers, 5 and 12. And then it was above 38. Above 38, there was 1. So below 14 was 5 and 12. Above 38 was 40. So there were 3 outliers. 5, 12, and 40. Any questions on that? Positive. Okay, so it was 1 through 9. And I think some of these are all the same. Number 2 was a mean. And then inner quartile range. Let's find the mean of this one since it's less values. Let's see, we did the mean. Let's find the mean. Mode. We found median range. The mean, you add up all the values and divide by how many there are. So we need to add all of these up. And if you add all of them up, you get 347 divided by how many there are, which was it 14. Rule of thumb is to go 1 decimal place past your data. So our data was integers, so I went 1 further, 24.8. If you look at the numbers here, we have a 1 decimal place. So then if you find something and you need to round, you should go 2. So go 1 decimal place further than your data. 24.8. Any questions? So our average is 24.8. Remember, mean means the same as average. Add them all up, divide by how many there are. Mode, most often, MO, most. Which one repeats the most? There's 3 26s. There's 2 23s. But the one that repeats the most or has the largest frequency is 26. And the range is the largest minus the smallest. I will probably have one where I have you find mean, median, mode, range. Just to make sure quartiles that you know how to find them. Largest minus smaller, and it won't have much more than this because I don't want you spending 10 minutes trying to add all the values and then make a careless mistake. Largest minus smallest, 40 minus 5, 35. Interquartile range, we know how to. I was looking to see if there was any other one. Okay. Any questions? Mean, median, mode, range, 5-number summary, and box plot? Any questions? A histogram I may ask you to read a histogram on the in person, but the take home you'll have to graph. First thing you need to know is how many bars you want to have. Now, if we look at our data, there was 14. What you want to do is take the square root of your sample size. N is your sample size. And this one, there's 14. The square root of 14 is 3. Three to 4. This is how many bars you'll have in your histogram. No, I would always round up. So 4 bars. For the units, you take your range and divide by the number of bars. Our range was 35. Our bars, we said 4. So our units could be 8 or 9. I would round up no matter what the decimal. If it was 8.01, you want to round up because you may not have, it may not go all the way to 40. If that happens, then keep using the same unit since you already started it, but keep going until 40 is included. Now, the other thing you have to remember when you're doing it, say 40 ends here, and we didn't go another unit, the bars go up to and including 40 goes into the next one. So you include what's at this one up to, but not including 40. 40 goes into the next one. So you have to have one unit past your number. So let's see what happens. We'll start with our first number, which was 5. And then we're going to count by 9s. Forty's included, so we're fine. These are our numbers, whatever they stand for. This is how many times they occur. This is frequency. So to get my bars, I took the square root of the sample size and used the larger value. If you go with the lower one, sometimes some are missing. Like it doesn't go all the way to the 40 that we needed. Units is your range divided by the number of bars. Again, use the larger, so 9. And that's why I counted by 9s. What I want to do is look at my data. And I want how many values are from 5 up to, but not including 14. And that's 2 of them. These 2 go up to, but not including 14. The next one is from 14 up to, but not including 23. Notice it's only the 22 then, because 23 goes into the next bar. So it's only 1. 23 to 32. 23 up to, but not including 32. 1, 2, 3, 4, 5, 6, 7, 8, 9. Histogram, the bars will touch. And one more. 32 up to, but not including 41. There's 2. 4 bars. Any questions on that? I think that's everything from the first section. Range, bar chart. Shows the death rate. Did I put number 5? Yeah. Okay, so they're talking about this bar graph. Bar graph should not have ranges of values like this. It should be written like a histogram because it's continuous data. But this is showing the deaths. And the reason it's skewed to the left is because with all the health care we have now, not very many people are passing away until they hit their 70s or 60s. And so that's why it's skewed. And it makes sense that depending on your health, but for most part, the majority of people pass away when they're 65 or older. And it's nice to see that this 85 plus is at the highest one. But it's skewed because with the medical that we have now, most people do not pass away when they're younger. I won't put that on the test. We didn't talk a lot about skewed, and they only have one problem in all of this. But any questions on it? One through 9. I think those all ask the same questions. So try some of them, make sure you understand how to make the histogram, the box and whiskers. But 1 through 9, 11. I think it's the same thing. Yeah, it's also just a histogram. So that will be from 5.1. Just those graphs and mean, median, mode, range, interquartile range. Any questions on them? .2 is probabilities. Times it. Yeah, we have time. 15 to 25. And I will try and keep them basic and not too. Probability can get really difficult, so things that I think will be more difficult, I will put on the take home instead of the in class. Let's look at 15. 2 fair 6-sided die are rolled. Write out the sample space for this random process. Okay, so when you're talking about the sample space, the first thing you want to do is decide out how many outcomes there are. So then you can make sure you find them all. Now, if you're rolling 2 6-sided die, or you can even roll 1 die twice, it's the same thing. If we're rolling the 1 die and then the other die, are these events independent or dependent on each other? When I roll the first die, does it change the probabilities depending on what comes up when I roll the second one? So say I rolled a 6 in the first one. Does it change the probabilities when I roll the second die?
No.
Correct. It doesn't. So these two are independent events. You definitely need to know the difference between independent and dependent events. Independent events, first event does not change the probability of the second. Now, if they were dependent events, first event changes probabilities for the second one. If you needed to explain that, decks of cards are an easy way, or a jar of marbles. If I had a jar of marbles and I pulled out a red on the first event, but I didn't put it back, now I don't have as many marbles as I started with. Or a deck of cards, you have a deck of 52 cards. If you pull out a card, if you don't put it back in, now you only have 51 cards. It changed the probability. So if you don't replace, it changes probabilities. If we replace the card, now I have all the cards when I go to do the second event. It didn't change it. If you need to explain, which you probably will have to, the difference between independent and dependent events, a jar of marbles is an easy one to use to explain the difference, because if you keep the marble, there's less in there. And I guess we could do one with that. Let me just make one up. Let's do 6 red, 5 green. Hmm. So we have 20 marbles. I want to find the probability. First red, then green. No, these two events, you can find their probabilities separately and multiply them together. If we pull a marble, what's the probability of the first one is a red marble? 6 out of 20. Because there's 6 red out of the 20. Now, to make this independent, we need to replace that red marble. If we keep that marble, then we only have 19 marbles. We've changed the probability for the second one. But if we put it back in, we've left them independent. So the probability of the first one, the red, is 6 out of 20. We put that red back in. The probability of the second one is green, 5 out of the 20. Multiply across. 30 over 400. And unless it states percent or decimal, you can leave it a fraction and you don't have to reduce. If we have any questions on that. Let's do one more with the same probability, both red. And we're still doing replacing it. So go ahead and find that one. So if we're doing it with replacement, the probability of the first one's red, 6 out of 20. So I pulled that red out, but I put it back. I'm replacing it. So now I still have 6 red out of the 20 when I pull the second one. Multiply across 36 out of 400. Any questions? To be dependent, when we draw the first marble, we don't put it back. And then we draw the second. So when we draw one, say this one here, the red, if we don't put it back, now we don't have 20 marbles anymore, we have 19. And so you're changing your probability. So if we find the first one, the probability first is red, then green. When we pull the first one, the probability of red is still 6 out of 20. But now we only have 5 red, 5 green, 4 yellow, 3 blue, 2 orange, 19 marbles. I've changed my probability, and that's why it's dependent. The second one depends on what happened in the first one. Now to find the probability of green, I still have 5 green, but it's only out of 19. $30 out of 20 times 19 is 380. Any questions on that? We'll do the other one since we did it above. It's both red. So go ahead and find the probability they are both red. Six out of 20, but then I didn't put that red back, so now I use this probability. The probability of pulling another red, now it's only 5 out of 19. Oh, it ends up, that's right, there was 5 greens of it. Notice this was 36. So it does change your probability depending on which one it is. Is there any questions on that? There's definitely one on the test where you have to explain the difference between independent and dependent. Go back now to number 15. When you're finding your outcomes, and this was rolling 2 die. When they are independent, you can look at each of the outcomes separately. So when we roll the first die, there's 6 possibilities, 1 through 6. When we roll the second one, there's 6 possibilities. 6 times 6, 36. So if we write the whole sample space, there needs to be 36 of them. And it is asking us to, now on a test, at least in person, I wouldn't have you write all of them. Okay, so when we're looking at it and we're not adding them, we're just looking at the two numbers on the die. You could have a 1 and a 1, 1 and a 2, 1 3, 1 4, 1 5, 1 6, and then a 2 with a 1, a 2 and a 2. And then a 3. And a 5, and then a 6. So if you count them, there's 36 of them. Any questions on that? If two fair six-sided die are rolled, what is the probability the dice shows the same number? Now, by having the sample space, it's easy to visualize how many have the same number. There's 6 of them. 1 and a 1, a 2 and a 2, 3, 3, 4, 4, 5, 5, 6, 6. There's 6 out of 36. While we have this one up, you will need to be able to write them as a fraction, decimal, and percent. There's probably one where I'll have you write it in all 3 forms. To find the decimal, just divide them. 6 divided by 36 is 1, and the 6 repeats. So 0.1, I don't know, 67. To find the percent, you multiply by 100, 16.7%. Any questions on that one? Let's see if some of these keep using the fair die. Number 17. If two fair six-sided die are rolled, what is the probability at least one die shows a 6? Well, all of these show a 6. And these. But notice I didn't overlap. You don't want to count this twice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Out of your total 36. So be careful you don't count the 6, 6 twice. Any questions on that one? Um, 18, complement. Remember, the complement is 1 minus the other. So it says, find the complement of at least one die shows a 6. It would be 1 minus the probability it does show a 6. (25 over 36). Any questions on that? So this goes up to 25. We did 25. This was a problem on attendance. So you should have that. But look at these and see if you have any questions on any of them. And we will continue next class. So we have 3 days left. Any questions?